Okay, so now that we've seen our benchmarks here, those are the benchmarks we're going to use here in answering question number 1 here. So number 1, part A, is asking me to give an approximation for the weight of a car. Well, the weight of a car is probably going to be measured in tons. That was actually one I gave you when we decided the different examples. Again, it's probably not the best example anymore since they're changing the weights of cars to make them more fuel efficient, but it's still probably closest to tons than anything else. It would be a lot of pounds, and I do mean a lot of pounds. So ton is probably a good approximation for the weight of a car, being similar to the weight of a buffalo. Diameter of a soup can. Well, remember, the small unit we have here is inches, and we know what an inch looks like. The only other two we have are feet and mile. Well, we know what feet and mile look like. Feet would be a really big soup can. Miles would be, oh boy, a really big soup can. So really the only one that even makes sense there by elimination is inch. A couple of paper clips across is probably pretty close to the diameter of a soup can. And then the weight of a newborn baby, well, you know how we weigh people in this world, so that one should be really easy for you. That's going to be in pounds. Yes, that you could probably make a case for ounces, or perhaps pounds and ounces. For instance, if the baby weighed 8 pounds 6 ounces, but pounds is probably the predominant measure we're going to use here. All right, so now that we've seen those, let's go ahead and go down to what we're really going to spend time on here, converting measures here. They're asking me to convert 5,000 pounds to tons in number 2 here. Now, you can see some work that's on the page, but we're going to approach this a little bit differently here. So you're going to see me doing something totally different on the side here that you're also going to use in working out your answers. What we do to convert measures is called a T-chart conversion here. So all you have to do is just basically make yourself a little T. Okay, it's a little bit elongated, but it is a T. And you're going to fill in information in each of those 4 boxes to help us to convert from, in this case, pounds to tons. What you want to do, this bottom left box first off, you're just going to scratch that out. And that's going to be true every time today because we don't need that box of information at all. We will eventually use that box, but today is not that day. So you can just scratch out that bottom left box every time. This upper left box in the T that I've created there, that's always where you're going to put whatever it is you're starting with. And what we happen to be starting with is 5,000 pounds. So we're going to put 5,000 pounds in the upper left box here. Now, what you're going to do over here now is put a conversion factor. And the conversion factor is hopefully going to be something that takes us from where we're starting to where we're ending. We're starting with pounds, we're ending in tons. So I want a conversion factor that takes me from pounds to tons. So we either want to know how many pounds are in a ton or how many tons are in a pound. That's what I'm going to fill in on that right side. Well, where's that information? Well, that information is in the book as well. So here is that list of information for you as copied from the book. This is an exact copy of what you'll see in the book. Obviously, if we're talking about a weight here, we're going to look here under this column that says weight, and we see right here it says that 2,000 pounds is a ton. That's a conversion factor. It's going to tell me either how many pounds are in a ton or how many tons are in a pound, however you want me to say it. But that's a conversion factor. And that's what I'm going to fill in on my table. Now, you can't always find one that'll take you there directly, but in this case we can. So we're just going to use this one. If you can't find one that takes you there directly, chain some things together. For instance, if I was talking about a weight and I gave you how many ounces it is, and I wanted to know how many tons it was, converting from ounces to tons, then I would chain the two together that we see under weight. What I would do is I would convert from ounces to pounds and get an answer. And then once I have it in pounds, I would convert from pounds to tons. So it's a couple steps, an extra step based on comparing it to the problem we're doing right now. But that is all you have to do. You just chain them together. You do multiple T's here to get you from where you're going to where you need to be. But again, we're only using the fact that 2,000 pounds is a ton here. So let's go back to our table and see how to fill this in. Now, you can't just write this in any way you want. What you have to know here is units cancel diagonally. And the reason units cancel diagonally, I want you to think of it like reducing fractions when we're multiplying. If I've got 3/4 and I'm multiplying it by 5/6, right, one of the things we can do is on this diagonal of 3 and 6, I could chop 3 out of each of those. Because 3 divided by 3 is 1 and 6 divided by 3 is 2. And then what I would do is I would multiply across, and I'd have a reduced fraction already. It's the same thing that's going to happen here, but instead of happening with numbers, it's going to happen with words instead. So what we're going to do over here is we're going to put the 2,000 pounds as a ton over here. But again, knowing units have to cancel diagonally, I'm going to put, since this is pounds up here, the other pounds thing is going to go down here. So that's where the 2,000 pounds is going to go. This is where the 1 ton is going to go. Now the nice thing is, once we see these units canceling diagonally, notice what I haven't crossed out. I did not cross out the T for tons. Well, that's great, because where does my question ask me to go? My question asks me to convert this into tons. Well, I'm there, because that's the only unit I haven't crossed out. That's the way you're going to know that you did this correctly. Then the only mistake you could make is simple multiplication and division. All right? When you don't cross out the one unit where you're supposed to be, unless you did something really silly, you're where you're supposed to be. It's easy. All right, so now what you do to find the numeric value is you simply multiply across the top, multiply across the bottom, and divide the two. So on the top, we've got 5,000 times 1, which is 5,000. And on the bottom, you've got 2,000. So this is 5,000 divided by 2,000, or 5 over 2, which reduces to 2.5, and that's 2.5 tons. Same answer that they got, of course, but computed in a totally different way. All right, let's go ahead and take a look here at number 3. Number 3, Allison orders a 6-ounce grilled chicken sandwich. Dominic orders a 1/4 pound grilled chicken sandwich. Which sandwich weighs more? How much more? Now, obviously the problem is here that these are hard to compare because they're in different measures. One is in ounces, one is in pounds. So what you want to do to compare them is to convert all to pounds or all to ounces. As you can see from line 1 here, what they've decided to do is convert all to ounces. So we can do that. So let's go back to the table. We're looking for a conversion that involves ounces and pounds here. And if we look at our table, we're in the same column for weight, and we see right here that it says that 16 ounces is a pound. So that's the conversion factor I need. That's the conversion I'm going to use to write up my T-chart here. So, again, I'm going to do work a little bit differently here, so I'm kind of going to ignore what they've done here. Remember, when you make this giant T here, this bottom left box always gets scratched out. And up here is where you put what you're starting with. All right, what you're starting with is a 6-ounce grilled chicken sandwich. So I'm going to put 6 ounces up here. And then over here is going to go to the conversion factor I saw in my table. Again, since I'm converting to ounces to pounds, that's why I wanted the conversion that has ounces and pounds in it. That's the simple logic. Remember, units have to cancel diagonally, so since something with ounces is up here, something with ounces always also has to go down here. So since there's something with ounces up here, other ounces thing down here to make it go away. So the 16 ounces is going to go down there with the 1 pound up top. That's ounces canceling ounces diagonally. I have not crossed out pounds. That's how I know I am where I'm supposed to be. So now, once you've gotten to the unit you need to be in, multiply across the top, multiply across the bottom, and divide the two results. So this is 6 times 1 is 6, over 16. If you want to reduce it, you can reduce it down to 3/8. And 3/8 is going to give me 0.375.